Okay, guys, I'm going to give this a try here. I'm doing things a little bit different for this one. My next topic is systems of equations. And luckily for us in the 8th grade, systems of equations is fairly simple. The bottom line is systems of equations is when you have two linear equations that are graphed on the same graph, and basically the systems of equations is where do they cross. So if you look at this graph right here, and let me see if I can zoom in a little bit here, you can see that right here the graph is crossing, or the two lines, the two linear equations are crossing each other at 575. So the systems of equations for this particular scenario would be 575. Now obviously I'm going to put a lot more background with that, but that's the basics of it. It's where did the two linear equations meet at the same point, and that would be at 575. Now that can be in a graph, and that can also be in a table. And I will show briefly a quick example of that, but the most important thing is that we understand why are we doing this? What's the whole idea behind this? And the idea is that when those two lines cross each other, they actually mean something. And I'll give you an example here. So this is one of my favorite ones to use. And that's a little too zoomed in. Let me back this out. So this is two linear situations. It says, move that down here. Jose has a beginning balance of $200. That's his y-intercept. That's the starting point. And his savings account and withdraws $25 every month. So there's his slope, negative 25. And you can see right here it says Jose is negative 25 in plus 200. So he started with 200 and he's withdrawing 25 every month. And my fingers look red. That's weird. Okay. Moving on. Then down here it says Tatiana has a beginning balance of $25. That's the y-intercept. That's your starting point, and then deposits $10 each day. So if you look at the equation, it's starting with $25 and then adding $10 each day. So from these two equations, I've already gone in and filled in a table. So if you look at the table, when you're trying to figure out what the systems of equation is, where are they crossing at? What's the solution? Okay, that's the word you'll hear it is. What's the solution to the systems of equations is the same point. Where are they crossing at? So on a table, where they would cross at is where they have the exact same point. So what I do is I start down here 0, 200, 0, 25, 175, 135, 2, 150, 2, 145, 3, 125, 355, 4, 100, 465, 575, 575. So at 575, that's where they have the exact same point. So that means this is where they cross. So on the graph, same thing. One of our scenarios started at $200 and then withdrawed $25 every day. That was Jose. Okay, drew $25 every day. And then Tatiana started down here with $25 and added $10 every day. So what I want my students to understand is that what does this whole thing mean? Well, in this particular scenario, you have one guy, Jose, who started with $200 and was pulling out $25 every day, and then you have this Tatiana who started with 25 and she's adding $10 every day. So what does it mean when they meet at the same point? What does the solution to this systems of equations actually mean? Well, what it means is this is the point where they have the exact same amount of money. So on the 5th month, it's hard to see down here. If you look at the x-axis, it's hard to see, but this is 5 right here. So on the 5th month, that's what the 5 is. They have the same amount of money, and how much is that? It's $75. So when you look at the coordinate 575, 5 is the month, 75 is the amount of money they have. So once again, you have Tatiana that started down here at $25 and is moving up. You have Jose that started up here at $200 and is moving down. When they cross, that's the point where they have the exact same amount of money, which is, again, $75, and that happened on the 5th month. So that's the idea behind systems of equations. And I should have said solution earlier, but it's all about the solution. The solution is where they cross. And in every scenario, it's going to be different. So I'll give you one more example, and then I will shut up here. So let me see. Zoom in on this one. Okay, so this one's about a submarine. And this is the U.S. Navy is conducting drills with their fleet of submarines. Good for them. As one submarine is ascending, so that means they are going up, and the second submarine will begin its descent. So that one is coming down. The first submarine ascends from 400 feet. That's the starting point. That's the y-intercept, below sea level. and sea level. The first submarine ascends from 400 feet below sea level at a rate of 10 feet per minute. The submarine that is descending from sea level descends at a rate of 15 feet per minute. So if you look at my equations, here's the guy that starts at sea level. So his starting point is 0. So that means this is a proportional relationship. We start at 0, 0 because they're starting at sea level, which again is 0. And he's going down 15 feet per minute. So that's negative 15 because we're going down. The one ascending started at negative 400 feet, and he's coming up at 10 feet per minute. So that's why it's a positive 10. So once again, let me show you on the graph here. So if you look, let me see if I can raise this out. It's kind of hard to see this one. This one's really spread out. But looking at the graph, this is the fourth quadrant. You know, your quadrants go 1, 2, 3, 4. So this is in the bottom right-hand corner. So if this is my x-axis, everything is below the x-axis because we're talking about water. Well, the x-axis is sea level. Everything below the x-axis is below sea level. So the one submarine started at 0. That means he was at sea level, and he was descending at, I don't remember what it was. I think it was 10 feet. No, it's 15 feet per minute. So every minute, that submarine is going down 15 feet. This submarine started at negative 400 feet below sea level and is coming up 10 feet per minute. So, you know, it's kind of a crazy one here, but the bottom line is when they have the same point, the solution to this systems of equation, when they're at the same point, that's where they crash into each other. So they will crash into each other on the 16th minute, and it will happen at negative 240 feet below the sea level. So they did not have that one on the table like they did on the other, but if it was on the table, we would sit here and we would go down the table until we found the same coordinate, and it would be at 16 when they would have the same y coordinate. So once again, this is systems of equations. The solution is where they cross. You can be given a graph and say, okay, this is the point. You will have to graph the line, okay, but you will have a graph and two equations to graph the line, or they will have the graphs on the equation, and you just have to tell at what point they cross at. That's why these are pretty simple. Now, these are going to get a lot more complicated next year when you get to high school. But right now, the only thing you have to do is graph both lines and just say at what point they cross at. And it would be a good idea to review this a couple times so you can apply it to a real-life scenario. It helps you to understand it. Now, if given a table, it's the same thing as the equation. It's just a little bit more complicated. I'm sorry, it's the same thing as the graph. It's just a little bit more complicated. On a graph, you just simply look at where they cross, and that's it. On a table, you're going to have to go down and see where they have the exact same coordinate. So like in this example, it was 16, negative 240. You would go down here until you ran into 16 and saw that they both had the same y coordinate, which would be negative 240. And so that is systems of equations. All right, they're all about where the two lines cross, and you can either see it on a graph or on a table. So the last thing that I want to address is they'll ask, you know, what kind of solution is it? Is there one solution? In other words, they only cross at one point, and you give that point where they cross at. There's no solution, which means they never cross. Or there's an infinite number of solutions, which basically just means it's the exact same equation. So let me zoom in on this a little bit. Okay, so these are the notes from my class. So if you want to look at these further, just go to the systems of equations in my Canvas and look up the notes, and these are the notes. But this is the best example I have, so I wanted to use it. But the bottom line is if you have one solution, they have different slopes. In other words, you're going to have one slope doing one thing and the other slope doing the other thing, and at some point they're going to cross. I hate to make it sound, you know, kind of blatantly simple like that, but it really is. It's just you graph one point, you graph one equation, you graph another equation. At some point, they're going to cross each other wherever it's at, and that's the solution. So there will be one solution. There will be one solution if they have different slopes. Like these two examples here, we have positive 3 and negative 4. So these have different slopes, so there'll be one solution. In other words, there'll be one point that they cross at. Next one, no solution. If you look here, the slope is exactly the same. They're both 5. So they're both going up 5 and over 1, which means they're both at the same angle on the graph, which means they will never cross each other. They're actually parallel. So if the equations have the same slope, but different y-intercepts. That means they're the exact same equation. They just start at different points. They're going to run right next to each other parallel, and they'll never cross each other. So there is no solution, because again, the solution is where they cross. If they don't cross, there's no solution. So what you want to look for is, do we have the same slope, different y-intercept? If that's the case, they're never going to cross. There's no solution. The last one is an infinite number of solutions. In other words, they have to be the exact same equation. So what they'll do to try to trick you is they'll give you something like this. See it? There's a line going here, but it says y equals 4x plus 8. Well, if I divide the 2y, the 8x, and the 16 by 2, it ends up being y equals 4x plus 8. So this is actually the exact same equation as the top one. The y equals 4x plus 8 is the same as 2y equals 8x plus 16 if you divide the whole thing by 2. So the bottom line is they have the same slope, they have the same y-intercept, they're the exact same equation, they're directly on top of each other. So where do they intersect at? They intersect the entire time. A line is made up of billions of points, and those points are overlapping each other at every single point on the graph. So in other words, there's an infinite number of solutions, because that line can go in both directions, an infinite amount. So that means that there's an infinite amount of times that it's going to be crossing over each other. So same line, infinite solutions, because it crosses the whole time because they're directly on top of each other. Same slope, different y-intercept, they never cross each other, so there's no solution. Different slope, they will have one solution because they'll cross at one point. And that's systems of equations. It's all about where they cross. That's the solution.